Zahra from Bloomberg. I'm just going to do the last talk. Thank you.
Okay, hi everybody. I hope you've been learning a lot today. So, as Stu has just mentioned, I am from Bloomberg, hence the extremely corporate PowerPoint template. I apologise for that. Hopefully you can deal with a lot of Arial for the next 20 minutes to half an hour. So, as might have been given away by the slide if you've been reading carefully, I am not actually a React Native developer. I usually write native code all day, and you might be thinking, oh no, the square brackets, they're coming. But yeah, that's essentially what this talk is going to be about. So sorry about that. So today I'm here to talk to you a little bit about React Native and how it interfaces with native code. So I know you might be thinking, well, isn't writing like literally no native code the whole point of React Native? I don't want to look at Objective-C, I don't want to look at Java, I'm here to write JavaScript. Well, I think with any computing concept or new framework, I think understanding what happens at least one level beneath, even having a cursory understanding of that, is really important and can really help inform your knowledge of the limitations and abilities that you have with using that framework. So that's what I'm here to talk to you about today. So let's have a look at a sample React Native application, very basic. So say I've written an application which has a ton of functionality, including displaying emoji and some text. So, we've got some very simple code here. We're just rendering some different elements. We're returning a view. We're returning some text labels. So the interesting thing is, we're writing this in JavaScript, and as has been mentioned before, this is turning into a bunch of native elements, and that's kind of cool, but we don't really need to know how that works, right? Well, no, you don't, but I think it's really interesting, and it can inform a lot about what happens with the framework, including performance, things you can do. So let's see how we go from this to this. Okay. So what exactly is happening? We know that there's some stuff happening on the native side. So today I'm going to take you through what's happening in iOS when you start to render some different elements. So first things first, we'll talk about the Tale of Two Runtimes. So whenever you run a React Native application, you have the JS runtime, obviously, you're writing some JavaScript. And you have the native runtime, and technically on Android it's 3 runtimes, but I'm not going to get into that. So how does it work? Well, you've got the JavaScript realm and the native realm, as I have mentioned. And both of those sides are really fast, they're really good at what they do, they're quite mature, had some really expert developers working on them for years. So we don't have to worry about those too much. The thing is, though, that those can't talk to each other directly. I mean, JavaScript and Java or JavaScript and Objective-C aren't directly interoperable. So we have to deal with these two things working in separate silos. So how do we get from both of them talking to each other? So this happens through, as has been mentioned previously tonight, the bridge. So any information that you want to send from one side to the other, be it native to JS or JS to native, has to pass over this bridge. So how does this actually look in terms of our sample application, which I'm going to show you about 10 more times tonight. So, okay, I'm going to take you through how it works on iOS. It's very similar to how it works on Android as well. So to start off with, we have the two separate runtimes. We have iOS and we have JavaScript. And we want to start up our React Native application. So what happens is that on iOS, we also have the bridge. That'll come in handy. So what happens is on iOS, it wakes up and it essentially says, hey, can you start this application for me, please, JavaScript? We want to run some React Native code. And then JavaScript says, okay, I'm going to run this React Native code. That's what I do. I'm just here to satisfy all of the web developers who are here to write mobile apps. And we look at the render function next. So we call render, and then it says, okay, there's a few elements. I want to render a view. We want to render a text label and an emoji and another text label too. So now that we have that information from the render function, it goes back over the bridge and basically says, hey, iOS, can you render these things for me, please? 2 text labels, not 1. And iOS obliges and says, okay, I'm going to make a UI view, which is the native UI element in iOS, and also a pair of text views as well, and it's going to display them. And anytime you have some sort of interaction between iOS and JavaScript, as I've said, it goes over the bridge. So this is something to bear in mind. So a few interesting things about that. Obviously, as I've said, Objective-C and JavaScript, or Java and JavaScript, aren't interoperable. So we rely on JSON to go over the bridge because that's fairly easy for most programming languages to use, except if you've ever tried to actually decompose some JSON in Java. I can tell you, there's a lot of exception handling. Anyway, additionally, you'll notice that when these messages regarding render and what needs to be rendered came up, they didn't all go one by one over the bridge. That's because these calls are batched, and as we're dealing with a lot of asynchronous programming in JavaScript, this also works asynchronously, which is quite natural for a JavaScript developer, maybe not so much for a native developer. So let's zoom in a little bit into each of these 2 sides and see what's going on. So let's take a look at the iOS side first. So in the native runtime, there are a few things going on. We run 3 main threads that we care about. So we have the main thread for the UI. This, if you take nothing else away about native programming for mobile today, it's that you do your UI on the main thread, don't do any networking on the main thread. The reason your animations look so buttery smooth is because you're not doing anything else on the main thread that is unnecessary. So that's just one thing to bear in mind. We also have a JavaScript thread, which is where the majority of your business logic and JS execution happens. And then the next one, technically not a thread, but details. And this is where your diffing and layout computation happens. So basically the core sort of layout algorithm of React. And additionally, we'll be talking a little bit about native modules and how you can use them in your code. But just something to bear in mind, each of these has their own queues as well. And as mentioned earlier in the Q&A with Joe, the JavaScript runtime is a JS engine, JavaScript core, which started off as an Objective-C wrapper around WebKit, which is the engine that Safari, the web browser, uses. So this comes for free with Objective-C and iOS. This is how you execute JavaScript in iOS, essentially. And yes, it is a standalone JavaScript execution environment. We're not dealing with any web views, any sad reminders of the days of Titanium and PhoneGap and what have you. This is what really makes things work really fast and gives you some great performance. And, sorry, just to bear in mind, I've mentioned it's an Objective-C wrapper, but the React Native team have kindly ported this over to Android for us. But as mentioned, this doesn't come for free in Android, so this does add a little bit of weight to your application. I think it's about 3 or 4 megabytes, so not too much. Well, maybe a bit much for 2 text labels and a view, but hey. So you might be thinking, okay, this sounds kind of interesting, but how does this affect me? Like, I'm just gonna make a cool React Native app that doesn't really need any native functionality that isn't already implemented. Well, there's something really cool called the message queue class, and it has a function on it called the spy function. And I've been talking about this sort of theoretical bridge or whatever, and it's like, yeah, but that's really deep within the React Native source code, right? I'm never going to deal with that. Well, something really easy you can do to sort of see this in real time and see this happening with your application is to drop these 2 lines of code into your application. So you just import message queue. It's already part of React Native, so no libraries or anything needed. And then anywhere in your JavaScript code, you can basically say message queue.spy true, or you can drop a function in there to do whatever you like with the printing, essentially. But what that basically gives you is when you run your application in debug and you choose to debug your JS remotely, you get something a little bit like this when you run our handy sample application that we've seen before. So you might be thinking, oh no, wall of text. But essentially, taking a little bit of time to read this and decipher it really clears up what's going on when JS and native code are talking to each other. So I apologize if it's a little bit small, there's a lot in there. But on one side, we have an indication of which direction this is going in. So you'll see N to JS on one side, or JS to N. That indicates which side is going to which side is talking to which side. And you'll see a bunch of different things going on here. At the very top, we've got app registry.run application and the name of our app, which is essentially the wake-up call from iOS to JavaScript. And we have a few different things. Here it's mainly JavaScript telling the iOS UI manager to make these native views and display them. So you might be thinking, okay, this is still cool, but like, I'm not going to use this, right? So one thing this can be really handy for is if you have some performance problems, say you're implementing an animation, something that can happen really easily is that you hammer the bridge with a lot of information about your animation. So you're sending consistently points, but not if you use animated.value, which I have learned today. But when you're using libraries or implementing animations, this can be a real source of pain when it comes to performance. So this is something that you can quickly use to diagnose those issues. And I think it's just really interesting to watch sometimes. Yes, I do have hobbies other than programming as well. Okay, so we've had a little bit of a talk about that, and you're thinking, okay, theory, theory, theory. What about the practical side of things? So as well as taking this understanding away, I'm going to show you some Objective-C code, and I am really sorry. But essentially, I'm going to take you through a few examples of how if you have an iOS library or some iOS code sitting about, as many JavaScript developers do, I'm sure, how you can integrate that into your React Native application. But in all seriousness, if you do want to use things like, you know, the latest and greatest APIs, so do you want to use a shiny new API on iOS or Android? WWDC is coming up, Google I/O is coming up, they might unveil something really cool and you want to use it, but unfortunately it's not part of React Native yet, then this is something you can do to try and get access to that. Do you want to use a library that requires you to React Native link? This is what's going on with that underneath. So if you run into any issues, hopefully you'll come away feeling a little bit more confident about dealing with those. And if you want to use any functionality that is currently not provided by React Native, or some, you know, very nice person on GitHub who has provided one for you, then this is something you might want to look into. Yeah. So I'm going to start off with just a quick reminder. So Joe mentioned earlier that there are a couple of different ways to make a React Native app from scratch. So you can either use Expo or create React Native app, which are the slightly more sandboxed versions and take you one level up from the native code. So in that case, you need to eject. So that means essentially you won't be inside the cozy bubble of building that provides you anymore. You will have to deal with Xcode or Android Studio. They're not as scary as they may seem, I think. But anyway, to get those started and to get them running, at least in a development environment, is generally not too difficult. You can get a free development account for Xcode these days, so you don't have to pay anyone to get it to run on your device anymore. Yay! So that's the case. And if you're using React Native init, then this is already done for you. So the output of either of these steps is essentially that you'll have an iOS folder and an Android folder which are available, and this is what the iOS folder looks like. So this is an Xcode project. It's just a bunch of files. It's not going to eat you, don't worry. So we have a few things going on here. We have the app delegate, which is basically the thing that does all the things in iOS. That's essentially the short description, but essentially that is your launching point for a lot of things. You have some assets. You have this info.plist file, which basically gives you a chance to define a lot of permissions and things like that. And you have some other things. They're not really that important for this presentation. You can go away and look at them if you want. I doubt you will. So, okay. So to use any native methods or modules in our JS code, the first step is to make a bridge. Now, I'm not going to take you through the nitty-gritty of this. I'm just going to tell you that there is this really helpful library or command line tool, whatever you want to call it, by Peggy Raises, which is available on GitHub. It's called React Native Create Bridge. So essentially, you just install this with npm. You run React Native, and then there's a command which I can't remember. I think it's new module. It's all in the README. But essentially, it'll set up some template iOS and JavaScript files for you, where all you have to think about is the implementation of that code that you actually want to include. And we're going to go through a really basic example. So let's say, for example, in my super cool sample app that we have some need to discover what sort of authentication the user is using at the moment. This is a very, very far-fetched example, I will acknowledge. But essentially, this is something that is not too difficult to implement. You can, like, if you wanted to do this yourself, I don't think you even need to understand Objective-C. You can literally copy and paste this off Stack Overflow. But what's going on here? So don't worry, I will explain everything. So we have an implementation file for our module, so as is mentioned at the top. So with any Objective-C code that we want to export as a module, we just use this macro, RCT export module. That just means, I'm a module, React Native, look at me. And then we have a few options for what we can do. So we can just export a dictionary, which is kind of like JSON. So say you had some constants on your native side that you wanted to export, that is very easy. And then if you want to export a method, that's also fairly easy too. So we have this other macro, RCT export method, which wraps a function. And say we want our module to have this function get biometry type, and it returns a string. So say the user is using face ID, it'll just return a string saying face. If they're using touch ID, it'll return a string saying touch. And if they're not using any sort of biometric authentication, it'll just say there's no biometric authentication. So there is some very interesting biometric authentication checking code that I have literally off the screen. It's about here somewhere. But I'm not going to take you through that at the moment because I'm not here to talk to you about the fine details of the authentication APIs in iOS. Essentially, imagine that we have made a variable called biometric type or biotype, and that we want to return that. All we need to do to get that value from the native side into the JS side at this point is we can use callbacks. So as you can see, my method is called getBiometryType, and it takes an argument here of RCT response sender block, but that's just a really fancy name for a callback, and I've handily labeled it there. So if you just wrap this, so what we have here is we're calling callback. The first parameter is an error, but as we know, this is really bulletproof code that is not going to throw any errors. So we're just going to return a null value for that. And then we just return whatever variable we want to return. We could return a literal. It's very flexible. And then if we wanted to use that in our JS code, all we need to do to call this module is to drop a few lines of code into any of our components or other code that we wanted. So you import the native modules section of React Native. You can then assign it its own variable for convenience, not even necessary. And then you can just use it as you would normally use functions with callbacks in React Native. So we just call that function, we pass in we provide a function with 2 arguments, the error and the type or the result, and then we can use those straight away. So just console log the error if we get an error. Otherwise, we can use it with set state. We can use it wherever we want in our application. You can go wild, do whatever you want. You're all the JavaScript developers, so you probably know better than me. So, okay, so we've done that, and what does this end up looking like? Well, I ran this on the simulator about 3 hours ago, and this is the result. So when I have the simulator mocking touch authentication, I've got it to display touch authentication in this label using a small bit of JavaScript in one of my text views. Otherwise, when I disable touch authentication, I am not using any authentication, and that's basically all of the code I needed to write, bar about 10 lines of Objective-C to get this to work. So it may seem quite intimidating, and I still find Objective-C quite intimidating sometimes, but really getting from iOS or Android to JavaScript, a lot of the difficulties have been extracted away by, the folks who do open source. So I don't think people should feel constrained by what's available in React Native. Getting started with iOS or Android development within React Native the barriers aren't as high as they used to be, and I think it can be really interesting, especially if you want to use new features. As well as callbacks, we have a couple of other options. So we can use promises. So instead of RCT export method, what we can do is we can return a promise instead if we want to do any asynchronous programming. So this makes using async await possible. It can be much nicer. So I've actually included a little bit of the Objective-C here that you would need to do it. It's about as verbose as Java can be. But essentially what's going on here is that at the top we provide 2 blocks as our arguments for this function. We've got a resolve block and a reject block. So this line essentially asks the device, can you tell me if this device has any sort of biometric authentication on it? And if it's successful, we're going to do some fun bio-auth checking, Objective-C or Swift type thing there. And essentially, at the end of that, we'll just resolve with the actual authentication method. And if it's not successful, we want to reject it and handle it in our JavaScript code. So that's what you can do there. I'm not going to show you a promise because I'm sure you know what that looks like already. And you might want to do something a little bit different. So instead of using callbacks or promises, you might want to be monitoring for events in iOS or Android. So that's also possible. We can use event emitters instead. So that's a little bit different. So on the actual module level, you have to declare it is an event emitter, as we have done at the top. So this essentially means that our module is subclassing RCT event emitter, which is the module provided by React Native. And then every function inside there essentially can broadcast a message to React Native. So you can set a listener for it in the JavaScript code. So say you want to monitor whether the users change their fingerprints and you want to wipe some data or something because you can't trust that their fingerprints are the ones registered on the phone anymore. So that's an example of something you might want to do. So if we want to use this in JavaScript, we just need to also import native event emitter, and then we set up a new native event emitter that takes in our module, and we subscribe to it, and I've put the wrong name in there. But imagine that says biometry info emitter. So we can add a listener to our event emitter, and we can check for the name that we have registered in our native code, if it's spelled correctly. Sorry about that. But essentially, it's looking out for an authentication update message from this emitter. And in that case, if we have got an update, we're just deciding to console log there, but you can do whatever you like. So say we were doing calendar manager emitter instead. If somebody sent you an invitation and you wanted to display something in your React Native code, that's quite easy to do. You can just add whatever JavaScript you want to do there. And just something to bear in mind is that you want to actually unsubscribe from the events afterwards when you're not using that component anymore, otherwise that'll just be left there dangling and impacting a little bit on your application and user experience, so don't do that. And voila, we have imported a little bit of native code into our React Native app. You might be thinking, what just happened? There were so many square brackets. But I hope this kind of goes to show that there's not too much involved in actually adding some native code into your React Native application. Sure, you might want to get a buddy who knows Swift or Objective-C or Java to start to help you out, but I hope this gives you an indication of where to look, not to feel too afraid if you're looking into helping out with an open source React Native project that uses these things and get an error. Essentially, this is the foundation of React Native, as much as we may not want to look at it. But I think it can get very interesting to use as well. And just to recap what we've looked at. So today we've looked at the bridge, we've looked at the 2 runtimes, or 3 runtimes, that make up React Native. We've looked at how to bridge native modules into React Native. I haven't had a chance to cover everything because obviously there is a lot of information here, but 2 important things I think that if you want to go away and look at this a bit more is adding native views to React Native. So as well as adding regular functions, you can build an Objective-C view. Maybe somebody has implemented a really cool charting library in Objective-C and you want to use that in React Native rather than re-implementing it completely. That's something you can do. And also, I have more experience with this, but adding React Native into existing native applications, that's also quite straightforward. So I would say if you are working at a small company or a company with some existing native applications, maybe you're struggling to hire some native developers, or maybe you don't want to hire any more native developers because everyone keeps talking about square brackets and it's just really getting to you. In that case, if you want to take a look at how you can get some React Native views into your application and maybe get more of your product development team working on it, that's something that's really worth looking at. It's not too difficult to set up, especially if you're using industry practices like, I don't know, using a dependency manager and things like that. So that's something you can definitely look at as well. I have a few links if you care to look at them. Unfortunately, I don't have a link to my slides right now. Hopefully, I'll be able to tweet that out later. But essentially, there are some really interesting articles on how this all works if you are interested. And just to describe them, the first one is the React Native Create Bridge open source project that I mentioned. There is an article by one of the React Native team about how this all really works in depth. And then if you want to have a look at Ray Wenderlich's website, that is essentially very iOS focused, and they have a really interesting article on how to actually get started with mixing and matching, like in a very practical way. So if you do want to take a look at this and try to follow along, that's something to really look at. And thank you very much. And here are some random pictures of our office building that I probably didn't put in there. Yeah.
Brilliant, thank you. That was great, thank you very much. Has anybody got any questions?
Hi. You mentioned the square brackets thing, and also you did mention Swift. So are they on a par? Can I write native modules in Swift and get away from square brackets?
Yeah, definitely. So the thing is that with any sort of interoperability things, usually Objective-C handles it a bit better, but you can definitely write it in Swift. I write mainly Swift myself. Objective-C is a little bit foreign to me. So as I mentioned, that open source project, it actually gives you a few options in terms of which languages you want to use. So that you can choose between Swift, Objective-C, Java, and Kotlin, if those are more your thing. Swift and Kotlin are very similar, and they're quite similar to JavaScript, so I think they're quite friendly. I actually gave a talk about a year ago on how similar Swift and JavaScript are, so if that's something you're interested in doing, that's really open to you.
Great, thanks.
Any more questions? Yeah.
Can you hear me? Cool. Feel free to discard it if it's out of scope. I'm just wondering, you said once you eject, you get like 2 different folders, one iOS, one Android, and then you have to build the, the bridges for the native modules and so on. So what happens if I try to use that app in Android?
So at the moment, we don't have an Android implementation. So what I would suggest is first you build the Android implementation before you try to use this app. But otherwise, there are things you can do. Like say you had a module that you only wanted to use in iOS, you can quite easily, for any component, I don't think this has been mentioned tonight, but if there are any components that you want to implement in different ways in iOS and Android, you can do that by actually putting your component name .ios.js or .android.js. So say you had this module only available in iOS, you could actually just only use it in the ios.js implementation rather than just putting it in the general component, and that means you don't necessarily have to implement it on both sides if there's no actual equivalent. I don't know what would actually happen if you tried to run this on an Android phone, though. I suspect very little.
Cool. Any others before we go? Okay, great. Thank you very much, Zahra. That's great.